And my name is Dave Morse, and I'll be your host here for the next hour or so to talk about trends in the manufacturing design industry. And some of the things I wanted to talk about today were starting with the global influences impacting design and manufacturing. So the global middle class is growing faster than at any time in history.
Are
Can
you
you hear
sharing
me?
your screen?
Oh, thanks. You got to remind me to do that.
That's
I
on me.
apologize. I apologize. I
No, no worries. I'll
apologize.
let you know when we can see it.
Now let me know when you can see it.
All right. Just loading. It'll take a few seconds.
Okay.
All right, you're good to go.
Awesome. Very good. All right. So again, what I wanted to talk about starting off is some of the global influences impacting design and manufacturing. So we'll talk about more. The global middle class is growing faster than any time in history. There are 400,000 people that join the middle class every day, and that's good news. With this increasingly urban population comes an inevitable demand for more of almost everything: housing, cars, smartphones, highways, hospitals, new and repaired infrastructure of every type. More demand doesn't guarantee more jobs or more quality. And as we make more things for more people, we increase the potential for negative impact. So let's talk about less. The more we make, the fewer resources we have left. Less limited natural resources, less skilled labor to go around. Manufacturing and construction already face skilled labor shortages. We also waste a lot. 30% of global waste comes from construction. 70% of spare parts are never used, resulting in inefficient supply chains, wasted warehouse space, wasted materials, and wasted time and money. So how do we make and build all that humanity needs while balancing this with less negative impact, less depletion of resources, less waste, less harm to communities, less carbon emissions? We have a capacity issue, and we have to rethink the way we make things. This is the biggest design opportunity we've ever had. So now we have an opportunity for better. Automation advances presents opportunities to do things better. We'll talk about that later in our slides. For decades, traditional automation helped us offload tasks and optimize processes. But it's imagination, not optimization, that moves us all ahead. A new relationship that combines human innovation and computer automation is helping people imagine new kinds of auto parts to make and new kinds of neighborhoods to build. Things that are better. For example, Autodesk customers like GM are making cars that are lighter, stronger, less complex, and more fuel efficient. Or Dutch builder Van Wienen is making housing that costs less. It's reducing risk and increases profit while giving residents more yard space and more daylight. So then let's talk about the challenges in our traditions and how we currently design and manufacture. So while trying to answer the challenges that face us in the design and manufacturing, we find that our current workflows present their own set of challenges, which we need to overcome if we are going to continue to remain competitive and rise to the top or stay on top in our respective markets. As you read the bullet points here, I'm sure you can identify with at least one of these challenges. Alyssa, what I'd like to do is just get kind of a pulse on the audience, and maybe we'll throw up the questions and see kind of where they're at as it comes to how they see things in their industries. So if you all take a couple of minutes to answer these, that'd be great.
Everyone, if you could just click the radio button that you think applies, and the more answers we get, the better. So don't be shy. We'd love to see what you have to say. And I'll leave that up for a couple of seconds. And a few more. And I'm not going to push it out. I'll push out the answers a little bit later. Do you want to go to the next one? Dave, are you there?
Yeah, let's go ahead and go to the next one.
All right. How often are you required to modify a design in order to meet reduced weight or material to benefit a design? Move that up for a few seconds. It looks like someone was trying to call me in the middle of that. And I'm just going to push it back to you. I'm going to forego the other poll question right now.
Okay. All right. Sounds good. All right. So we'll take a look at those later. All right. So let's take a look at some of the trends now in manufacturing that are impacting the way we work and the way we design and build. So, we're at a crossroads and have a once-in-a-generation opportunity with a lot of the new means of production, the changing consumer demands, and the nature of products. So these are the three key trends that are reshaping the way we do business. So the nature of the products themselves are changing, as the incorporation of software provides the ability to embrace smart product development and deliver products that are more intelligent and connected to the world around them. Increase in demand from customers who expect products to be more precisely tailored to their needs, delivered in a shorter space of time, and providing increased value beyond the point of sale. And finally, an influx of new technology like generative design and new forms of manufacturing techniques capable of realizing far more complexity in the production process, such as industrial additive techniques, leveraging metal-based printing. Let's look at a couple examples of how the nature of products is changing. Autodesk and Airbus have collaborated to create the world's largest 3D printed airplane component. The bionic partition was created with custom algorithms that generated a design that mimics cellular structure and bone growth, and then produced it using additive manufacturing techniques. This renders the structure stronger and more lightweight than would be possible using traditional processes. The bionic partition is 45% or 66 pounds lighter than current designs. When applied to the cabins of the current fleet of A320 planes, Airbus estimates that the new design can save up to 465,000 metric tons of CO2 emissions per year. That's equivalent to 96,000 passenger cars off the road for 1 year. That's quite an impact. Let's take a look at this thermostat. I'm sure we're all familiar with this. There's nothing wrong with this overall product. It does two things perfectly. It turns off and on and changes your temperature from hot to cold. It's a nice design and works great and is reliable, maybe too reliable. But it's just a piece of hardware. It can be easily copied. Customers might change very easily to a different brand, and once you sold it, you have nothing else to offer to that particular customer. With the introduction of software, manufacturers are able to develop their products that are capable of being able to adapt to their environment and the users that operate their products in ways that are previously unimaginable. If you own a Nest, you are engaged. I own a Nest. I think they're pretty cool. The thermostat learns the behaviors of your house and makes decisions for you. You can engage with your thermostat remotely via an app, which connects you to the Internet of Things. Nest sends the reports on your energy consumption quarter to quarter, year to year, raising your awareness of the environment. Bottom line is, products are becoming increasingly intelligent. Software is added and not only extends the value, but software also adds value throughout the lifetime of the product. Software enables the vendor to provide services on top of the product, enhance it, and understand the usage. And out of the usage patterns, new business models can be generated. And this is how the nature of products are changing. But the connection of that software to a cloud platform takes its advantage further and allows manufacturers to differentiate their products by delivering a completely new level of value. Think of the increase in value that internet connectivity gave your phone with the advent of smartphones. Now imagine that level of value in every other manufacturing market, and you will see how smart product development becomes so critical as it allows manufacturers to build a network of value in a way that is highly defensible from their competitors. And ultimately, vendors turn products into platforms to offer extended value and connectivity between formerly disconnected devices. The platform protects the consumer, and vendors create competitive differentiation. Compare this to the original thermostat. If you are happy with your innovative thermostat, the company is gambling that when you want to purchase a camera or a smoke detector, that you will stay within the platform of products that they created. This is the competitive differentiation that manufacturers strive for. How is production changing? Well, we're seeing three major impacts on how products are designed and manufactured. The important point is they're all happening at once. First is collaboration. The nature of design will be increasingly collaborative. As technology connects more and more people to more complex projects, we're going to see global virtual teams and collaboration on a scale unheard of. Capital. Our access to capital is changing. Crowdfunding lowers the barriers of entry and creates more opportunities for market research. With greater access to capital, it levels the playing field between small and large companies. Now, ideas and products of the future can come from individuals, companies of any size, and from any part of the world. Computing. Our computing infrastructure is dramatically transforming. Access to virtually infinite provides vast amounts of data at any time and anywhere through cloud, social, and mobile technology. On the bottom right here, you see an example of a cylinder head from a Toyota engine. Looking at the cross-section, you can see the complex lattice design. This is a perfect example of the convergence of generative design tools used to create the lattice structure, as well as using additive manufacturing to print the designs that previously were not possible due to design software limitations and without the advancements in additive manufacturing. This part cannot be sandcasted nor machined. The only way to achieve this design is to use generative design software and additive manufacturing techniques. The benefit of this technique is the lattice structure can be optimized. This component saves weight over traditional outdated methods, and the performance is increased as the structure works as a heat sink for thermal distribution. Finally, allowing the engine to run at a higher pressure and higher temperature and improving fuel efficiency of the vehicle, providing better performance. So what is happening behind the scenes of the lattice structure is an incredible innovation design. Let's walk together through the basics of generative design. Design has been the same way for hundreds of years. Get an idea, iterate on that idea, decide which design is best, go into production, and hope you have a blockbuster product. The problem with that approach is that the very beginning of the stages, how many different concepts can you create? How much time do you have? Is it 3? Is it 10? You're limited in the time it takes to create your concepts before you have to get into production and show a return on investment of that product. What if your products could help design themselves? The design team still plays an integral role, but the true leaders will leverage new technology to create the differentiation of their products. By leveraging artificial intelligence and tapping into the unlimited cloud computing power, the design team can employ this strategy, are in a position to become true market leaders. By having the computer create hundreds or thousands of design options, you can now make your business decisions not only on aesthetics, but truly finding the best designs available to you. So what is fueling the change in the products we buy? We're seeing a greater integration of the digital and physical. Digital systems are becoming deeply integrated in physical things and are creating complex interrelationships among physical objects. Pervasive internet connectivity, the power of the cloud, and the ubiquitous and inexpensive sensors mean that our places, things, and media will be connected, intelligent, and dynamic. Sensors monitor their behavior, they collect and disseminate data about their use, and they can respond to their context, other things, and us. Internet-connected things can gather and stream data about how they are being used to offer valuable insights and respond to the needs of the end consumer. They also have the potential to create new insights for those who design and make them, helping us better understand use and improve them over time. And because of this connectivity, designs will be optimized not only for how they function, but how they are built and interconnect with other systems. Let's take a look at a few of these products. This is what you and I as consumers spend our money on, and I think it's safe to say we want to invest our money in the latest and greatest technology. As I talk to people in the design and manufacturing world, I might be told, "Oh, I can't make my product smart, or have an app, or it won't work with the Internet of Things." But let's look at a couple of examples of how intelligence of products are changing. On the top left, we see a robot. Robots are not new, but the behavior of robots are beginning to change and evolve. Humans are good at sensing and problem solving, while robots are good at strength and repetitive actions. With enough software expertise, robots can learn finesse too. So on the top right, you also see about Audi vehicles. Talking to U.S. traffic signals is a first in the industry. Many people sitting at red light actually experience anxiety. They're in a hurry. They got somewhere to go. They've got an appointment they've got to get to. So the Audi has developed technology that will allow a countdown to actually appear, so it gives the person the idea of how long the light is going to be red before it turns green, and that helps to relieve much of the anxiety of waiting. I never knew that people experienced anxiety at a red light, but there it is. On the bottom left, we see an overflowing garbage can. It's ugly and unsanitary. Big Belly Trash Cans is an example of a company that is taking waste management to the next level in the creation of smart cities. The trash cans are solar powered, operate for a week on the energy it takes to make a pot of coffee, and They hold about 5 times the volume of ordinary trash receptacles, requiring only 1/5 the number of trash truck pickups, and send alerts when they are full. The last example is about hydration. We hear all the time the need to increase our water intake for various health benefits. Today, Thermos has a smart water bottle that notifies you when you have hit your hydration goals, notifies you with the amount of water consumed, time elapsed, and number of sips since the last time the bottle was refilled, and how close you are to reaching your daily hydration goal. So for those that ask about their products, we've just looked at robots, cars talking to traffic signals, smart trash cans, and a smart water bottle. So yes, product intelligence is changing. All of these devices have one thing in common. They are connected. They create data and they send data. The most important part of these connected devices is the 50,000 EC instances per day. EC is elastic computing. It's a concept in cloud computing in which computing resources can be scaled up and down easily by a cloud service provider and provision flexible computing power when and wherever required. The big driver is elastic computing is rising and the costs are declining. The takeaway is the costs of supercomputing is being put into your hands. No longer do you need to invest the huge hardware costs when you can leverage the cloud. The benefits are shown by leveraging artificial intelligence with the generative design tools to create the Airbus partition, the Toyota engine block, and others. This is what the cloud is really about. The design and manufacturing industry is defined by many vendors that have created categories such as CAD, CAE, CAM, that are focused on task-based applications. Over time, this process has introduced 3 sources of friction. In traditional product development process, businesses create and consume huge amounts of data, often in different formats, which do not work together and require lossy translation. Single users may require a multitude of tools to do their job, tools that have different user interfaces and experiences, resulting in an exponential learning curve and wasted resources. In order to take a design through to manufacturing, you need many tools from different vendors to complete this process. You basically have to be a PhD in the product development process to stitch these disconnected tools together efficiently. Everyone involved in the design and manufacturing process should have access to the data in a connected and seamless way. This is why Autodesk built Fusion 360. It combines design, documentation, rendering, simulation, and CAM around a common user experience and data model to help your business compete anywhere in the product development process. Autodesk is bringing together technologies that had previously been separate. By building Fusion 360 in this way, they're able to differentiate in the market in 3 main ways. With an integrated platform that makes it easy to connect all phases of your product development process, you can view data from a single source and easily collaborate with both internal and external stakeholders, and you can access your data and technology across devices from a single affordable offering. The manufacturing industry has evolved with new initiatives such as Industry 4.0 and smart manufacturing, and an ongoing focus around digitization. To take advantage of these trends, it's critical to eliminate inefficiencies in your current processes today. Traditional CAD platforms are fragmented, expensive, and disconnected, causing costly inefficiencies and exasperating challenges. Disparate software breaks down communication, and if changes are needed to be made, can create significant extra work. Poor communication, either upstream or downstream can lead to slow feedback and mistakes. Working in silos can also hinder improvements in performance. Finally, lengthy programming times, setup times, or inefficient cycle times can all contribute to missing deadlines. Go from design to machining faster. Design changes update toolpaths associatively made from Fusion 360 or other CAD tools leveraging any CAD. CAM programmers can collaborate with designers, engineers, and machine operators for faster decision-making and better upstream and downstream visibility to begin closed-loop feedback cycles at all phases of manufacturing. We've already mentioned access across devices, whether it's a browser or mobile, but also PC or Mac. Also, Fusion 360 comes with a library of open source, free standard post processors to post G-code to nearly every machine. In addition, there are free training courses on Fusion 360 website and thousands of YouTube videos to ensure you can learn Fusion 360 effortlessly. Autodesk is also providing access to advanced capabilities and technology through consumption services such as Generative Design or the Manufacturing Extension. Manufacturing has changed and is continuing to change, and so should your tools. Make quality parts faster, reduce cycle times, and increase your bottom line utilizing a single unified platform. So in addition to the plethora of traditional tools developed by Autodesk, such as our product design and manufacturing collection and everything that's in there, such as Inventor and AutoCAD, AutoCAD Electrical, AutoCAD Architecture, all of the flavors there. We also have Inventor Nastran and CAM solutions, all at our fingertips, and those all support any CAD. But we also have the Fusion 360 as part of that. And Fusion 360 was developed to live in all of the design spaces, providing a single integrated platform to bring design and manufacturing together. So some of the design spaces that Fusion 360 lives in is the 3D design and modeling, electronics, being able to work with different file formats between your parts with Fusion 360 and gain all the advantages, full-featured electronics tool and mechanical CAD. Simulation, you don't have to wait. You can test your designs early in the development process to determine usability and uncover costly flaws. Generative design. This enhances and expands your ability to innovate. Quickly generate high-performing design alternatives from a set of manufacturing and material constraints. Once a solution is chosen, edit your CAD-ready geometry. Documentation. Easily derive 2D drawings from your 3D models to ensure manufacturing accuracy. One of the big ones here is collaboration. You don't have to worry about locations, time zones, or extensive reviews that lengthen your development process. View all design data from a single project dashboard and easily collaborate with both internal and external stakeholders. And finally, manufacturing. Avoid costly rework, defects, and missed deadlines that impact your bottom line with truly integrated CAD and CAM. Utilize HSM technologies to quickly generate tool paths that cut cycle times, reduce machine and tool wear, and produce high-quality finished parts. So again, just looking at the traditional design process, we have our design exploration and our time to market. We are able to come up with maybe several concepts that we ideate on, and we go back and forth between evaluating those concepts, looking at manufacturability, and finally with validation before we can go ahead and produce our parts. And so we have a long iteration phase, which there's pressure there to get the parts out. And then our design to production is also lengthy with all the evaluation, manufacturability, and validation cycles that exist in the traditional design space. So with generative design, we can change that and we can explore different designs and let the computer do the work. And this technology is available inside of Fusion 360. So you can simultaneously generate multiple CAD-ready solutions based on real-world manufacturing constraints and product performance requirements. And so let's look at the generative design process. Here, our time to market is shortened because we let the computer do the work and come up with multiple validated manufacturable options. And instead of just a few, we can come up with hundreds or thousands to be able to pick from. And then from there, we select and go from design to production. So our time to market is reduced significantly, and we come up with parts that couldn't even be conceived before that are in every way equal, if not better than their traditionally designed counterparts. So there's our productivity increase. So some reasons to use generative design. We can improve our product performance by lightweighting, increasing the structural integrity, extend its durability, increase product innovation by exploring more design alternatives and expanding beyond what we could previously fathom in our designs. And also creates an innovative aesthetic appeal. It actually creates something new for our eyes to see and something pleasing. Lots of these shapes look very organic and mimic nature. And then finally reduce the product cost by doing part consolidation or reduce the amount of raw materials that we have to use. And this all leads to improved customer satisfaction. We're able to win more business, enter new markets, beat the competition, and get to market faster. With Fusion 360, you can ensure that all your design outcomes are manufacturing ready, and in fact, multiple manufacturing techniques can be employed. Imagine combining additive manufacturing with any of the other traditional and advanced subtractive techniques. This is called hybrid manufacturing, and it's going on today. And all your outcomes are CAD ready. So that's one aspect of Fusion 360 is the generative design. Next is the use of additive manufacturing, which Fusion 360 is tailor-made to help you get your product ready for additive manufacturing. And I just have a graph here just to give you an idea of the industries that are currently using additive manufacturing. So we have 47% in manufacturing. We have automotive, product development here, medical, aerospace, education, government, and electronics. So additive manufacturing has had wonderful advancements in recent years. And I actually saw recently where additive manufacturing techniques were actually being employed to make molds for casting. So real quick, does anybody have any questions of anything we've gone over? Alyssa, do you have any? Were you able to pull up any polls or anything like that?
Hey, sorry, I was on mute.
That's all right.
No, I think
Okay.
we are good to go right now.
Okay. Great. Well, that's all I have. I just wanted to, show some of the challenges, some of the trends, and introduce the wonderful Fusion 360 platform that we have to be able to answer those challenges.
We love to see it. Thank you so much, Dave.
Thank you.
And thank you to everyone for joining us today. We appreciate you spending your time with us and trust it was meaningful and impactful for you and your business. I look forward to seeing you on a future webinar. Thank you, everyone.